So it's not my usual time, but I'm trying to get a little ahead of the game here. So I wanted to do a live stream. I wanted to do it the other day and I didn't get around to it. And it's going to cover making this fork bell crank, or at least lay up the first part of it. So a little history here on this bell crank. You can see at the end where the lead outs go. You know, it's got a forked end on it. The old traditional bell cranks, for the people new and not real familiar with the whole deal, were made out of carbon fiber, and the lead outs, the cable went through this hole out here. And when you run IC motors, it was okay. There's a lot of vibration, harmonics or whatever, and these were okay, and I think they're still okay, but I'll go over, and I made another video about the lead out terminations. But as far as the forked end, it's superior in a lot of ways. Number one, it's a bell crank where you can take the lead outs on and off. So if somebody's flying a take apart airplane, you can actually, with a shoulder bolt or a C-clip shaft or whatever you put in here, you can actually remove the lead outs from the bell crank. And if you know, they're getting worn out on something like this, I mean, it's a little bit more of an involved process than it would be replacing them on the fork. So the idea is, instead of the lead outs coming through the bell crank and then squeezing down tight on the crimp, the brass tube, right here the lead outs are going to go around a button, and the button's going to pivot on the post. So everything's in line. It's a lot freer setup. I thought about this a long time, probably for a year, and I'm not a very speedy person as far as how fast I can get things done. I do a lot of stuff, get distracted, but anyway, I came up with this method of making this bell crank. At first I was going to mold it like this. I was going to make a mold, and the mold was going to be sort of complicated to where I was going to lay it up with a carbon toe, continuous toe, and then I was going to insert a metal plate in there to form the fork, screw that into the mold, and then continue with the toe on the top of it. And if you're watching this marathon video I had where I did almost 3 hours, and all I did is PVA and wax molds, and there's probably another hour where I put the surface coat in. And the surface coat basically is, you know, it's brushed in like that, and it's sort of necessary when you start packing the mold. It takes a lot of pressure, and there's a lot of packing going on with the carbon, so the PVA alone wouldn't hold up. So when you put the surface coat, you can jam that carbon down in there. So long story here short, it's a very time-consuming process. Takes a long time to make one of these. So what I'm going to do today is lay up this carbon fiber sheet on this mold, and this mold is going to form the sheet into a plate. Now this plate, obviously you'll see here, but the plate is actually going to follow the shape of this mold. And what I've done here to get the bell crank, I've glued 2 of these together, and it's glued together with high temp resin. So you got a top and a bottom bell crank here. So this plate has to be cut and then glued together, and then eventually there's going to be a oil light bushing just like here. There's an oil light centered bronze bushing in there. There's going to be little buttons top and bottom, and then there's going to be a bushing here. So that'll be added after the fact, once you get the top and bottom plate, you know, glued together to actually form this fork. And the whole idea of this process, number one, when it comes down to actually manufacturing these bell cranks, I'm not going to make them. I'm going to job it out. So I'll get a mold made and I'll send it off to the JT Composites. I talked to Julian about it and he's open to the idea. He'll work with me and help me. So the idea was to drop off the mold and they make plates. Okay, now the plates determined, I'm not sure the exact size. Right now I got just a test piece here. So I'm not actually making bell cranks today. What I'm trying to do here is make prototypes to test to come to a final conclusion on exactly what needs to be done. So this is still prototype phase. So then once JT actually lays these plates up, which will be this configuration here, it'll go to a water jet cutter and then they'll actually cut the parts out. So then all I'll have to do is take top and bottom, glue them together, and then install the bushing. And then the button, the post and the button or whatever we have here at the termination for the lead outs, that'll all be CNC machined, these little buttons. And we've thrown across some ideas where some of them would be round or some would be a teardrop shape. So whatever the configuration is, it'll be CNC machined. Now one of the beauties of this bell crank being water jet, you can actually go back after the fact. If something just didn't quite right and you need to reconfigure it, you can do it in the program. So you're not stuck to a mold. Let me get my dot going here if you guys have any questions. Okay, so that's just sort of an overview here where I'm at. So I'll put these away. I still have a bunch of landing gear to lay up. I was going to lay up the rest of this stuff tonight, but I thought I'd do the layup of this plate. So I'm not actually going to make bell cranks. I'm just going to show you how I lay up the plate. And then of course the plate actually gets you the bell crank eventually. So I got my stuff laid out here. I got my vacuum bag and I've got this aluminum plate. Okay, this is I can't remember the dimension, but basically this aluminum plate has got a bevel on it. And then when this is vacuum bagged on that plate, which the plate is sitting on plate glass, that's what's going to form the little, the joggle here, right here in the, which in turn of course is, that's what gets you the shape of the bell crank. So all I'm going to do is lay up plate carbon. So this was formed on a belt sander. It was a long process. I mean, typically you take this into a machine shop and they'd run you could even put it on a Bridgeport and just run a mill down there and it wouldn't take too long. I basically just sanded it in there. It's like sharpening a lawnmower blade. It wasn't quick, it wasn't that easy, but it got me to where I needed to be. So I got my glass with the release agent, I got my aluminum plate. You can use whatever release agent you want. Now, you can use wax and PVA, but you can get away without the wax and the PVA on this situation because there's no cross-linking. So the glass has got release on it and the aluminum does. Now the aluminum has got release on both sides, top and bottom, so that way if any resin soaks underneath the bottom, it'll still release. Okay, now here's one I liked. I used this years ago, back in the 90s. It's still relevant. It's called Loctite 700 NC. You just go ahead and wipe this on. It's almost like water, you know. So you wipe it on in a real small film, I mean a real thin film, not where it's wet, but it's just like damp, and you let it cure. There's something that happens with these chemical release agents, especially on aluminum or composite tooling. It'll actually cross-link to your mold. Is it cross-linking to the glass? Probably not, but I like to use chemical release agents on glass and aluminum and so forth. So the only reason I go to the PVA route on a lot of this stuff is because these molds are out of epoxy or urethane. And it forms a barrier between my mold and my epoxy. It makes the molds last longer. And you know, it's almost unlimited on the molds. The downside of the whole deal is the time it takes PVA to dry and put on. The other thing with PVA, you don't get the good finish. Now, if this aluminum plate's buffed out and the glass is buffed, you're going to get that same finish on your part. Now, if you watched any of these videos where these guys are making these gliders, you'll see the same thing. They'll be painting in the mold, and then when that part comes out of the mold, it'll look like plate glass. I mean, it's almost perfect, if the mold is perfect. So let me see here, I get this camera adjusted. Let me check the chat here real quick. Got any questions? Hi Steve, it's going good tonight. A little late, but it's going. And Robert Orlet, good to see you back. Yeah, Steve, the cost of the Bellcrank, it's one of these things where I haven't priced it out yet. At the Nats, these Bellcranks, I was going to bring maybe 10 or 12 of them. I was just going to sell them for 20 or 25 with the lead outs. And that's the same thing. I sold them for 1996, 98. So everything's gone up, but yeah, it's it's going to be the same at the Nats. The price of these Bellcranks, I'm not sure. I gotta get to that point where I can figure it out. Now here's the thing. If I can make these Bellcranks and I job it out, and let's just say, I'm sure the laser cutter, the water jet, to get a part like this cut out, I bet it's probably about, try to remember, I had some stainless steel cut 2 years ago, and let's just say it's $4. You know, they make 2 cuts, top and bottom, and that would probably be on the high end. That's the worst case scenario, I think. So the thing is with water jet, if you take them business where they run the water jet all day long and they're making thousands of them, the cost of the service goes down, or the cost of the part goes down, because you know they're in more production. If you take them 10 parts, you know they're going to kill you. So I'm not really sure about that, but worst case would be $2. So let's just say you got $4 in the water jet bill. Now the carbon, the pre-preg, I'll talk to JT, and once I come up with the dimensions I need, say, well, this is what I hand laid, and this is what it's got to be. So then they'll look at it, and I say, well, I got 6 layers of, 5K here, 12 or whatever the thing is. So they'll just pre-preg it, okay? So what that bill is, I don't know. Now, the Bellcrank, the old style, was 7 or 8 grams. This thing with the fork without a bushing in it is 10, and I think it's really heavy. It could be a little bit lighter. I could go through here, and you could probably put lightning holes. And one of the reasons I'm doing this tonight, when I lay this stuff up, I'm going to try to lay up to where I can get maybe 6 more of these things. And they're each going to be a different configuration. Some will have holes, some will be thinner, different whatever. And then I'll start destruction testing. I'll start pulling on them and I'll see what they'll take. And I'm pretty sure by looking at this and the properties, I'm going to be okay. So 10 grams right now, 8 for the other one. So my hope is that it'll be comparable. Now, I don't think I can make it lighter than the other one at 8 grams, 7 or 8, but I think I can get it at 10 or 12, because you got to put the buttons in there, you know. So I think it'll be comparable. It'll be within a, you know, 4 grams probably of the old one. And anytime you start adding more stuff, you know, there's no way around it. It's going to weigh more. So hope that answers your question on that. Yeah, we are a cheap bunch, ain't we? Yeah. Yeah. So I'll just see what I can get away with. Now, you know, we always talk about price of stuff. Now, okay, so let's just say this Bellcrank, let's just say, for instance, I had 25 bucks in it. You know, the everything, you know, my labor, the carbon, the pre-preg, and then the water jet. Now, if I can get this for 25 bucks, I'll probably introduce them after I pay myself to glue the halves together at 25 bucks. Okay, that's everything. That's paying me. I'd sell it for 30 to start out with. So my intention is initially put a decent price on them. And I told Sparky, I said, you know, if I can produce this Bellcrank and if I don't have to do anything but stick it in a bag and maybe just a couple little iterations, I said, I'm not really worried about making money at this point. It's just a matter, I just want to put them out there. I don't want to lose money. So that's the deal with that. I'm going to try to get it as cheap as I can. So what I've got here is some kind of visqueen, okay? This was, you can use monocoat backing or whatever. And what I'm going to do is lay this carbon up on this plastic. I'm not going to put it right on the mold. So the weight of this carbon, I wish I could tell you what it is. I walked into there's a place in Brownsburg, APC, ACP, I don't know what the heck it's called. I can't remember now. I walk in there and they got a place where you can walk in and, you know, buy retail leftovers. So when they get done with a job, let's say it's special order on a roll, they'll throw the partial roll or whatever on a rack. And I'll save enough of this scrap, so if this is what works out, I'll take it to JT and say, hey, this is what, you know, this is what I started with for the testing. And you can see this stuff's unraveling major. It's cut oversized. So, and I was telling somebody the other night, I said, you know, the price of this stuff, a Bellcrank, 3, 4, 5, 6. Yeah, so there's 6 layers. Yeah, the price of these Bellcranks, let's just say it was 50. I don't think it will be, but let's just say, you know, you get a Bellcrank for 50 bucks. You got to remember, if you fly RC and you buy one servo, I bet you can get $100 wrapped up in one servo. I was out there at the Screaming Eagles. They had an RC pattern meet, you know, with those, they got these biplanes now, contra-rotating props, you know, they got it going on. And I didn't ask him, but I know an iMac Bellcrank, I know you're talking, you know, or an iMac servo, I'm sorry, you're talking at least $100. So if you think of the Bellcrank as a servo, so being the cheap person I am, all this toe right here, I'm so cheap I save it. I put it in a bag, and if I do like a foam wing with ribs, I've done some iterations like that where I put the little I-beam rib into the foam. It's just like the lost foam thing in reverse, I guess. I take this carbon, this toe, and I'll lay it underneath the cap strip. So that's what I'll use that for. Now, I'm at the point now where I really need to mix up some resin. So you're probably thinking, well, you got this carbon here, how much resin? So my rule of thumb, I weigh the carbon, I think it was 150 grams for all this carbon. So that means, that tells me from experience what I need to mix up here. I'm just going to mix up 160 grams of resin. And if I need a little more, I'll do it. I think I'll use this good cup. It's got the smooth sides down in there. These Dixie cups and stuff, they're all right, but there's all the little nooks and crannies down there. So I'll go with this. Let me see the chat here real quick. We'll make some 700 NC would work on an iron mold with hot 425 HDPE high density polyethylene as a molding material. I make some honeybee equipment. Recycled plastics as sticking is an issue. I do know that these people that make this stuff, the mold release, they've got mold release for all different scenarios. So yeah, Sparky said go with 5 layers instead of 6. It'll lighten it up with a little loss. So 5 layers is a total of 10 in a BC. Yeah, that's another thing, Spark. We were over here looking at this Bellcrank, and if you remember, it was just a little bit thicker than the other one. So I could go with 5. I might do that. It's probably good advice. I think by feeling this and just trying to break it, I mean it's overkill. You know, it's stout. So I could go with 5, Spark. So let me see here. I'm going to get my resin mixed up. So I'll still go with 160. So let me see what my tear is on this cup. Don't want to screw up my math here. See the cup here. Okay, it's cup is 18.2 grams. I'm going to start writing this down on this deal, 18.2. And then I say I want 160 grams of resin, so let me go. We got 18, let's say 20, 180. So I'm going to pour 180 grams in there. What I'm going to do, the other prototype was made with this resin. It's HTR 250 and 106.3. So it's a high temp resin. It can be cooked. Now, I made a rocket tube. We were all messing with rockets for a while, and I thought, well, you know, this is a good time to start experimenting. So I took some HTR 250 and I wet out some fiberglass and I wrapped the mandrel and cooked it in the oven. I went up to maybe 250, 300, something like that. And I couldn't get it off the mandrel, stuck. And I thought, well, there's only two things I can do. I took it in the refrigerator or freezer and froze it to see if I could get it out. It's still stuck. So the other option was to stick it back in the oven and cook it to like 400 degrees, and still didn't release. So basically what I did is I took a drum, I scored it, got underneath it, peeled it off, and I've just basically, it came back and I ran some tape down in the center and seamed it So I didn't ruin my mandrel, and I didn't actually ruin the tube. It's still good. And when this stuff gets to 400 degrees post-cure, it's unbelievable. When you take that tube and you pop it on the glass, it has a really high ping to it. So you can tell the properties of this resin change as you take the temperature up to the max. Okay, I got 182.4, 2.4 minus my cup, 18.2, 164.2. Let's see, double check here. There's 64.2 plus 24%. 64. 203.6. Now, if you're doing a lot of stuff production-wise, Sparky does it, I've done it. Basically, you just come up with, okay, so I need 20 grams, so let's say 24%, it'd be 4.8. So if you stick with these simple things, you can do the math in your head. It's easy, but I'm winging it on this. I'm just coming up with a one-shot deal. So I need 203.6. It's a lot of resin. 203.6. 203.6. So my takeaway here is get everything lined up, because once you start mixing this stuff up, you know, you don't have a whole lot of time. So really, this is pretty comparable to like a Perky wing, you know, with whatever Spark was making on his Perky. He was doing one layer. So we're gonna go with 5 Spark. 1, 2, 3. We're gonna leave 1 out. We're gonna see what 5 gets us. So really, 5 and 5, and the Bellcrank will have a total of 10 layers of this stuff. And if it works 10 layers with the HTR 250, I guarantee it'll work with pre-preg. Another neat thing about the pre-preg deal, with this stuff they had some pre-preg. It was carbon, and they had Kevlar mixed in with it. And my son-in-law wanted a little hatch made for his electric guitar in the back. It's like you open up the back of the guitar and it's all the electronics. I said, well, I'll make you one of those things. So I thought it'd be fancy. So I come out here and I grab some of that scrap pre-preg I had. And I lay that up in between, let's see, it was a couple aluminum plates. So I overshot it just a little bit. Overshot it by about 1.5 grams. I was telling Sparky, I said, what you could do, since it hasn't been mixed, you could pour the curing agent off the top and add it back in. If you overshoot it, that's what I do. And you know what, with the way it was, I was probably okay. I probably could have actually gone with it. Let me get my stick to mix it up. Let's see here. Didn't seem like that was much curing agent. Let me double check here. After I poured that curing agent in, it seemed like it was a little less than I thought it'd be. So yeah, 164. 2. Equals plus 24% plus 18.2. 203.6. Yeah. All right. Yeah, you get talking over there, talking on the camera. It's easy to make a mistake. Yeah, it'll be interesting to see where we're at on 5 layers. Yeah, Spark, I still have those bottles. I just haven't cleaned them out. I looked at them the other day. Got a question for you. How do you clean those things out? You run some acetone down in there before you actually put the hardener in there? Or does the top come off? Just trying to figure that out. I tried to suck up some acetone in one and clean it, but I'm not sure I got it clean enough. Another thing, if you guys hang in there, or if you don't make it all the way through this video, come back and watch the tail end of it. When I finally get this thing in the bag and get some breather on it, it's amazing. I'm going to really work this down hard. I'm going to pull a full vacuum on this thing, and I'm going to take a squeegee and keep working and working and smashing this stuff down to get the properties I want. Now let me get my squeegee. I got it over here. Probably the other thing, second most important thing, is get enough paper towel. So, just the normal old pour it on and squeegee. Nothing fancy here. Don't worry about getting too much on there at this point. You know, ain't gonna hurt anything, because basically you're gonna really squeegee it down and suck it all out in the bag. I got my cat in the house. He's wanting out in the garage. I hear him at the door. So I use a squeegee to wet it. And this is just something I like to do. I like to go back with my fingers. I want to be able to actually feel what's happening. The other thing you can do with this plastic, you can turn it over and you can see if it's wetting through. So with my fingers, I really rub like this, and that works it all the way through the weave. So really what you almost think is too much turns out to be about right, starting out with. Now if you have a little bit of extra resin on top of this, the next layer will suck it up, so don't get too worried about it at this point. See, I can flip it over and I can see that it's wet all the way through. And the way this works anyway, I mean, when this goes on the actual plating or the mold, you know, you can always add a little extra here if you have to. There's one. Number two. The other thing to keep in mind, if you watch enough of these videos, you know you've got the chance of exotherm. So keep that in mind when you have a big cup. So this is important right here to me. When I was making bell cranks today, one of the things I do, I lay that toe in the mold, and towards the end of the process, when I actually put a little bit of chop around the corners and the pegs, I'll take my fingers without any paper towel. I'll blot up all the extra resin with the paper towel, and then I'll take my fingers and I'll push down over the top of the toe, and I'll push down really hard, and I just run my fingers over that toe, and you can feel like little Rice Krispies. You feel a little pop, you know, those little air bubbles. And as I run my fingers across this carbon, in certain areas, you know, you can feel a little pop. And that's the air coming out. Yeah, it'll be interesting when I actually start yanking on these things. And I was telling Bob, I said, if I can take these things and stress test them, and I get to 300 pounds and the bell crank hasn't budged, it's going in my plane. But it'll be interesting to see, you know, on some of them, I'll just see just how much they'll take. Now there's a guy, he's up around Speedway somewhere. He's just east of the track in this really old industrial area. And I came across his YouTube video. It came up in my feed. His name was Algae, or it's called Algae Composites, ALGIE, I think. Okay, but it really caught my attention because the first video I clicked on, he was making pre-preg out of a wet resin, and it was HTR 350. Not, this is 250, and he had a 8430. I don't know. It was one of the is the slowest curing agent you could get, and he wet it out on plastic, and the 350 with this curing agent wouldn't actually cure. You could set it over there on the, just leave it on the bench, and it would be just like just gooey the next day. It would be gooier, but what he was doing, he's putting it in the fridge, and then maybe it would go for a month or two. I don't know how much he was getting out of it, but basically he was making pre-preg, homemade pre-preg, and it was sort of a unique thing. It was but he was using resin services. Now, as I push and squeegee this, I mean, I've got loads of resin in this. A lot of resin. A lot coming out. So I'll try to remove some of it. We got, what, 2 more of these to go. But I was going to get some HTR 350. Never used it before, but I was going to try it. See my comments here. Yeah. 10 layers for 500 pounds. You're probably right, Spark. Yeah, it's unbelievably strong. The other thing is, if you get the strength you need with this wet layup and you transfer that into a pre-preg, I think you're going to be golden. It's just going to be even better. Yeah, the amount of resin I mixed up is about right. So, starting to feel pretty tight. You can feel this resin thickening up a little bit. So really that was about the right amount. I didn't want to run out. I sure as heck didn't want to mix up more with my gloves once I started swimming in this stuff. Yeah, I wouldn't have gone with 5 if I didn't think the 6 was plenty. But the properties I got out of the prototype Bellcrank, its 6 layers, was unbelievable. So let's try 5. The other thing, maybe, after the fact, you could orientate this stuff a little bit different, but this weave's pretty tight. Yeah, this stuff wets out really nice. The other thing you can do, even after you squeegee it, when you put your fingers down, you can feel how much slip you're getting underneath. You can feel resin-rich areas. You know, when you push your finger really tight, you can actually feel it sink down. So right over to my right is a resin-rich area in here. Okay, now I'm at the point where I need to start cleaning some of this up. I'm going to try to mop up a little bit of this resin. Obviously the plastic carrier is thrown away after the fact. That just goes away. So let me set this out of the way. Now, they had a couple different types of peel ply, and I bought some cheap peel ply at the place up here in Brownsburg. And I tell you what, it took a lot of force and a pair of pliers and really ripping it off. At first I thought I couldn't get it off, but when I went back to get this cloth, I had them give me some Teflon. And I thought, there's no way I want to go through that again. And the guy told me the Teflon leaves you a surface that is a lot finer. It's not as coarse as the cheap stuff. But he said if you have fragile parts, you know, where you can't really, let's just say you had one layer of carbon in a mold and it's real fragile, go with the Teflon because it peels easier. And he did say, he showed me some of the stuff they bonded. He said they do sand it, even though, you know, the Teflon release agent leaves a rough pattern. He said they still, before they secondary bond it, they'd sand it. So I got really good wet out. Had to get that out of the way for a second. Now one of the things I'll do eventually, I'll take this plate glass and put some felt or something on the back side of it if I keep using it. I've had trouble where I get holes in my bag where the bag, you know, touches the table and gets pinched. So this is where the beauty of the plastic comes in, obviously. You know, transfer this stuff without a big mess. With the plastic. And all I'm trying to do is just make sure that the carbon is centered over my aluminum plate. You know, and if you look at the Bellcrank, you don't have to have too much hanging over. You know. So just make sure that. And the way this is set up, it doesn't matter where it's sliding around on this glass as long as that carbon is straddling this aluminum plate. The whole thing has got release on it. So now at this point you can also squeegee. You come in here. Before you pull up this plastic, start working some of this resin out. And what that does is it saves the vacuum bag all that extra work. And I pay close attention right here to this hump. I work that down really tight. As I'm squeegeeing, I can see the air bubbles come out of this stuff. So don't rely on the vacuum bag to do all your work, especially on a wet layup. Don't be afraid to actually work this by hand. An autoclave with pre-preg, it's obvious when you have that system. Basically, you don't squeegee anything to get rid of the resin, you just squeegee it down to make contact. So I'm getting a ton of resin out of this, which is good. I'd rather overfill it and suck it out than not have enough. And once I get this thing under vacuum, I'm still going to do the squeegee thing. But the properties you get by doing this, the squeegee is, you get a really, really good fiber to resin ratio. So, and I just keep working. I try to keep it centered on the aluminum. I'm not sure of the mill of this plastic. It feels like a little bit heavier than what you'd get on the monocoat backing, but that stuff's good. The old monocoat backing. So I got this really tight. Looks good. Let's get rid of this and let's get some peel ply on here. Peel this off. Now to keep all this frame, you could probably put some tape on it, and that would help with all the fuzzies. Sort of going back to the question Robert had with the high temp injection mold, it might be worth a try. And I'll tell you what, Robert, when I was making parts, some of these parts when I initially started Bellcranks and landing gear, back in the 90s, they'd actually send a salesman out, and he'd actually come out, he'd look at what you're doing, and then he'd give you some pointers. A salesman isn't going to tell you all the secrets, obviously, of, you know, what somebody else does in their shop, but they've got such a broad overview of all the products. There's a good old salesman that's been around a while. There's probably not many scenarios that they haven't run across or seen. So nobody likes a guy showing up trying to sell you something, but I'll tell you what, in the composite industry, sometimes they can really be a help. So, but you know, I'd hate to say 700 NC. I know it's a high temp. I hate to say, yeah, it'll work, but and then have something stick. That's the problem, you know. You get to the point where stick your neck out and you're not sure if it's going to work or not. Now this first iteration I made, this first Bellcrank sample with this Teflon and it released, when it came time to pull this thing out of the bag, just like it fell apart. This is old leftover breather from something. Let's see here. All I got to do is cover the part. Now what you can do, you can take tape, you know, sort of tack it down with tape if you have to. Yeah, the old Winnebago. Oh man, funny stuff. I got some these clips. These clips, George Spar used to sell these things. I'm not sure where my short ones are. Whatever. These are a little long, but they'll work. Way too long. That's what I found. And start in the center. I'll tell you what, laying up this big piece here, a little bit more work than that little sample I made initially. That's why when it gets to the point where I'm kicking these things out, I'll pick up the phone and say, send them my way. Won't have to worry about all this. Be cut and dried. Okay. This is a part that I can get screwed up really easy. Taking this big piece of glass and sliding it in the bag. Probably the only thing I feel like I could need help with. Best thing to do if you do a lot of this stuff, don't do it on a hard surface, do it on a carpeted workbench. And that way it helps you get holes in your bag. But I'll be real careful. And it's not going anywhere. As soon as I get this thing sucked down in this bag, it'll stay right here. Alright, so I'll put a little water breather back here. Now you guys probably watch Sparky's same thing. Once you've seen one bag operation, you've seen them all. The takeaway here though is how much you compress that by hand. Even on a pre-preg, you really work that pre-preg under vacuum with tools down in corners and stuff. So just because the bag sucks down doesn't mean your job is always over. You got to really make sure the bag is conforming to all the nooks and crannies and you got the right pleats in the right place. And you know what I forgot to do? I got to get my puck in there. That's the beauty of having these clips. Yeah. If I had tacky tape, I had to cut it. So I remember when I bought this hose, it's like a garden hose literally. it goes to like 600 degrees or some ungodly temperature. This is all high temp. I bought this high temp stuff because if I ever stick it apart in my oven, you know, I got the fitting that'll take care of it. And when you put this puck down, I try to pull the plastic tight so I don't get a crimp underneath the silicone washer. And just finger tighten it, it's good. Yeah, I got a lab oven over there that's got a vent hole in the top. I don't know what it was for, but I'd stick my hose right down through the top of that vent hole so I can pull a vacuum in a 400, 500 degree oven or whatever. Now, I don't worry too much about little bag leaks. I got the pump that cycles, and it'll be good. It'll be good enough for this job. And then these are quick connects here. And I'll plug her in and pull her down. I think I'll pull it down first. I'll turn it on. This is like the Rube Goldberg of composites out here. Crazy stuff. All these wires. So I don't know if you could tell, but it sucked down pretty readily. You can see what you're seeing here around the perimeter is all the excess resin I previously shoved off of the part. And this is what I really like to do, is push really good right here on this corner. You want a really good corner in there. I got this, see, where in the heck did I get this bag? This bag in George Spar, it's oh, it was up in Wisconsin. Trying to remember. What the heck was the name of that place? I thought I had it on one of the. I got a label around here somewhere. Hey Sparker, still watching. Where did you buy this bag at? I told you to get it there, and you got some of it. What's the name of that place? I got so much stuff rattling around my head. All these numbers and crazy things. Man, that's a ton of resin in there. I'm going to fully saturate this breather, or the bleeder, whatever. But, you know, I'm not looking for production parts. All I'm looking for is a part that I can compare strength with, you know, when I work out the different configurations. So I'm pushing a lot of resin out of here. Now, if I was just relying on this bag, this extra resin wouldn't be coming out. Yeah. So the way it was explained to me, the way composites work, when you're pulling a full vacuum, let's just say it's 28 inches of mercury. You never get the full outer space vacuum, obviously, I guess, but when you're pulling full vacuum, you're looking at 17 pounds per square inch. And that's what kind of weight you have on this laminate right now. For every square inch, it's like setting 17 pounds on it. Now, fast forward to the autoclave. Now you got 100 psi or 85 or whatever they run it at. So you can see 5 times as much pressure on a bag plus the heat. And the way the autoclave works versus this method is, as I'm squeegeeing this, you can see air bubbles in there. So anytime you put an air bubble under vacuum, it gets bigger. Now the beauty of the autoclave is, let's say you get to this point, you turn on the autoclave pressure. So now you go from 17 psi to 100. And that bubble that wanted to expand is now being smashed. And it really becomes almost non-existent if it's done right. So they'll actually decrease the vacuum sometimes at certain parts of the cure schedule, I think, to allow the autoclave to take over. So I make sure it's massaged down right there in that crease. Let me see my comments, see if anybody's... Envision, yeah, that's it. Envision Composites. Yeah, he said stop, where's the air valve? Yeah. Man. Yeah, Envision. Envision Composites is really user friendly. I mean, it has been to me. They carry all the stuff that you'd get into a full-size shop. They carry all the high temp stuff. That's where I got this hose and the fittings. Sparks bought stuff from them. Bought some stuff from them. Obviously, if you're in a full-fledged deal, you probably buy in bulk cheaper. But I mean, if you're just gonna buy rolls or a little bit of this and a little bit of that, it's perfect. I think they're up in Wisconsin, up there in the Oshkosh area. So, but work some of this pleat out so I can rub this thing down. You know, I hope, looks like it might have scooted over a little bit. I don't know, we'll see. Yeah, there's probably enough. I think, yeah. I didn't want to waste too much carbon. Cut it too much oversized. But the beauty of this whole thing, if I figure out the design of this Bellcrank, and I can job it out, and obviously JT, I want them to make money if they want to do it, if they'll help me. It's got to be profitable. And if I can get this whole part down to where I don't have to do a whole lot of work but put it in a bag, you know, I'd be happy. Still moving a ton of resin. this resin, you know, started to get pretty thick fast. There's another guy that chimed in on this stream I was doing, and some of these guys that chime in and watch this, they're experienced. I think Robert, of course, he's doing something out there. But they've got a lot of information. They know what they're talking about. Tell by the questions they ask or what they say. So, one of the guys mentioned using RTM. The kind of resin you'd use when you vacuum infusion. So, he said it allows them to actually pull all the resin out of the part because it's thinner. The HTR 250 reminds you of sort of a West Systems. It's pretty thick. And let's just say this part I get out of here, let's just say it's not perfect. It really doesn't matter. As long as I can get the dimensions and the thickness of this part and get it pretty close to where it needs to be, then I'll turn it over to somebody with the right processes. This is just a way for me to narrow down all my options. So I didn't want to show up and waste anybody's time or waste my money. I'm trying to get all the guesswork out of it. And the way this garage is set up, it's not set up for production, it's set up for prototype modeling stuff. The other thing you can do, I think not so much in a wet layup, but one of the things that crossed my mind, the possibilities, let's say you're making this Bellcrank and you decide you need the fork to be a little bit open, a little bit wider, a little bit more depth to it or whatever. You can actually add one more strip of carbon here, and that will raise up the center section to where it make the fork wider. Or go vice versa, you could add an extra strip out here at where the fork is, one more layer of carbon out here, and you can close the gap of the fork. So you can vary a lot of things on this Bellcrank by using this method. The other trick is the cost. I think Derek, he asked a question about the cost. The cost is going to be contingent on how many Bellcranks I can get out of a sheet. And I got to talk with the JT, say, okay, how big does this plate need to be? Now, they got an autoclave that'll take a huge part. So, I mean, technically, you could take a mold of aluminum and have this hump milled into it, and that's the idea. Eventually the mold will have a block of aluminum with milled out channels in it with a hump, and I got to talk to them on just how big it can be. Probably the bigger the better within reason, because there's no reason to put a little plate like this in there in an autoclave. You want to make a run, you want to make them as many as you can in the same amount of area. The other thing we talked about, you can't nest these parts. Normally, if you'd have them out of a flat sheet, you'd take one bell crank here, and then the next one would be here. So the water jet they'd all be nested. The way this is configured, it's got the hump right here. So each bell crank has to go butt to butt, nose to nose. So it'd be like this, okay? So that limits how much you can get out of here. But what I'll have them do, in the areas in between the bell cranks, I'll have them cut out the buttons that go here, the little round circles, you know. So some of this material in between will be utilized. You know, there's going to be a little bit of waste, but I mean, that's all part of it, right? So that's all factored in. Basically, if you buy a bell crank, you're actually paying for the waste. That's the bottom line. You pay for the waste and the part. Yep, you just keep working this and keeps coming out of it. Right now, though, it's really tight. I got a good seal on this bag. Really, it's pulling down really good. And the pump kicks on a little bit, but not too much. Yeah, I'll turn this camera back on when I yank this out of the bag tomorrow, even if it is for 10 minutes. I'll show you how fast and easy this thing comes out of this bag. You know, Randy sold a lot of stuff, Randy Smith, and his business model was job it out. You know, those motors that Randy made, he assembled them, he put the fit, you know, he'd fit them all together, you know, made sure they were all blueprinted or whatever. But Henry Nelson or whoever's involved was actually making the motor itself. And that's what I'm going to try to do with this airplane stuff. I'm not going to be out here in a sweatshop. I'm going to job it out. So if somebody calls up and say, hey, I need 2 bell cranks, 3 days later it's in a box on their front porch. That's what they want. You don't want to wait on me to make it. So by jobbing it out, that's the only way I can think of doing it. A good friend of mine, some of you guys might remember him, is John Davis. And I used to fly with him. He was friends of Jack Sheeks and I. And he owned a business, it's called DeValco. And I don't know if you've ever been over to his house. Some of these guys have. But he had like a 2-bay garage, about what I got here, devoted to his business. And he would actually get an order and he'd go out there and reach in the bins and he'd get all these parts and he'd make the valve and he'd fit them together. So he was sort of doing like what Randy would do with the PAs. He would, you know, assemble them, put them together. So you probably notice I'm not giving up on this thing. I just keep working it. As long as I can keep it working and get it tighter and tighter, I'm going to do it. But if you look at this part, I'll bring it to the nets. You're going to see there's no voids in it, but between the weaves you're going to see like little spots, you know, there's no resin. But it's tight, there's no bubbles and, you know, there's no voids. But if this was pre-pregged, the whole thing would be like a mirror finish. That the resin, the carbon, the resin is perfect. I mean, it's just unbelievable how beautiful it is when it comes out of the autoclave. So right now, it's to the point where it's about as, it's tight. All that resin is out of the part. Let's see here, what do we got? Yeah, a linoleum roller would work great, but I don't have one. I had a little roller that was the roll down wallpaper seams. It was sort of like a linoleum, but it's smaller. The roller was about the size of a quarter. I can't find it. It's around here somewhere. So a wallpaper seamer roller is great. Okay, Remington made the case and Henry made the rest. Okay, so Sparky has a lowdown on the PA. Yeah, but buy the whole sheet. Let's see, I do that with checkered plated aluminum, the shiny stuff. If you want something made out of it, you buy the whole sheet. Let's see here, rub it, and you could literally have bolts in the middle of each Bellcrank if you had to. Yeah. Yeah, that's right, Robert. So I think now this squeegee, it works okay. I mean, it's actually peeling up quite a bit. It's moving the resin, and I'm not looking for perfect cosmetic or just something to where I get the properties right. I got my shop kitty over there. Every time you see the cat over there, every time the pump comes on, it wakes it up. Poor thing. He's not used to the vacuum pump. He likes that lawnmower. He'll sit up there all night, especially when it's hot. Get off the floor. He probably doesn't want the mice nibbling at his feet when he's sleeping, so he gets up on that lawnmower. You see him right there. He was out in the backyard looking at a chipmunk, and he was probably 2 foot from the hole. And the chipmunk had its head out the hole, and they were staring at each other. Wasn't doing anything, he was just looking at it. So he finally gets up and decides he's going to go over there and make a swat at that chipmunk. Well, it's 4 foot down the hole by the time he gets there. He never did get it. He's, as far as a hunting cat for mice and chipmunks, he's like a golden retriever watchdog. He's worthless. He's just, he's the best cat though. But boy, he sure doesn't catch anything. Now, I got 2 house cats in there. They'll kill anything in a minute. I go out in the back deck with a cup of coffee. It's 5 minutes and there's dead birds on the deck and there's mice out in the yard. They do a heck of a job. That old Ginger over there, he's laid back. Doesn't bother anything though. Let's see, what have we got going here? Oh my God, the kittens, yeah. Yeah, that's usually the way it is, isn't it? As soon as the kittens come, the dad beats it. He's out of there. I guess you have to take your, you know, get the balance, you know, to where, you know, the cats are still manageable, but they're doing their job on the rodents, you know. So, yeah, it's, that's pretty much it here. I mean, that's just all I was going to do. Let's see how many bell cranks can I get out of this crazy thing. Let's see. So there's one bell crank. Let's see, there's two. There's three, four, 4.5, and I got this plate here. So I could probably get 5 bell cranks. That's, you know, if I can get 5 more or 4 more, that'll give me enough iterations to actually get what I need. So I was watching a video, and they were talking about aluminum for molds. And they said if you use 2024, you can get a higher polish on it. Yeah, 6061, it'll polish, but 2024 will give you a better mirror finish. So if I get to the point where I got to get some aluminum machined, I'm going to do it with 2024, and I'll have it machined, and then I'll polish it. And the thing is, with let's just say I get JT to make these pre-preg slabs, you know, they don't even have to take them out of the bag. They just autoclave it. Just hand me the part in the bag. I'll unbag it and take it to the water jet. And the other thing that's I'll probably talk about real quick here, if you go on a tangent and you do all this stuff without contacting the parties that are involved in actually making your stuff, you get into trouble. And what I mean by that is, I'll take this sheet, or I'll take this whole process to JT, and I'll say, what's the optimum size sheet that you can do? What are your requirements for doing this pre-preg on this mold? And they'll be able to tell me, we'll do this, do that, have it this thick, the mold should be this thick, and, you know, round the edges, or whatever they're going to tell me. So I figure out what they need, and then I go to the water jet cutter, and I show them the part, and I show them the slab like I got here, and I show them the mold or the drawing of it, and I'll say, okay, what do you need to do to set up your water jet? So it's if your program is set up to nest the parts, if this plate moved around or whatever, it wouldn't matter. But the thing is, with this hump, each bell crank has got to be cut out over this hump, centered. So I'm thinking, if I go to the water jet laser cutter, what do you need to align this carbon plate in your machine so when it indexes, it's when you touch your machine off and zero it out and you put your program in, that each one of these bell cranks is over the hump. It sounds like something that wouldn't matter, but it is a big difference. So let's just say that water jet cutter, they say, well, what you need to do is when they make this plate, when they machine this plate, machine like little dimples or something. I don't know what they're going to tell me. So that way, when we take this carbon plate and we put it on our water jet cutter, we can index it, this plate, so it indexes with our program. And it's all based on where this hump is. The other thing is, if you had a 4 foot by 4 foot sheet, would it be beneficial to machine both sides of it? So in other words, you'd have molds on both sides. That's another thing I got to run by JT. So it's a way of doubling the capacity of the mold with, you know, the same square inches. The other thing to think about is, well, obviously the nesting and everything. So yeah, I think once I get to this point and I say, well, this is the part, it's going to be strong enough, this is the dimensions, and then I'll go from there. and I'll contact both places and see what I can come up with. So there's a lot of pre-planning to it. The other neat thing, let's just say you had a mold, and this measurement here, this hump, is based on a 4-inch Bellcrank. So what you could do, if you could just on an edge of a mold on one strip, you could actually have, you know, maybe one little strip or one area that's maybe 3.5-inch Bellcrank or 3, or I doubt you'd probably never have much need for that, but so you could vary the width of the Bellcrank by machining different humps in there. So that's something to be decided. But I'm going to bring these things to the Nats. Hopefully I'll get them all glued together in different configurations. And let's see what people say. I get a lot of feedback from people. They're really helpful when it comes to telling me how to improve things or little things I could do. But the way this is set up now, it's really flexible. I mean, you can vary the amount of carbon, you know, like Sparky said, go with 5 sheets, so a total of 10 instead of 12. And I think, you know, I think he's right, and we'll give it a shot. And so it's just it's one of these things where everybody thinks I design it, and basically what I do, I figure out how to solve all the problems. But I mean, heck, I didn't design the fork Bellcrank. I just had to figure out how I was going to process it, you know. It wasn't my idea to come up with a fork Bellcrank. It took me a year to figure out how I was going to make it, though. So Sparky used to call up John. I had to laugh. He was talking about the wheels. Sparky goes over there and he's selling John stuff for Barb, you know, giving Barb the money. He said, my God, he said, I come over here and John's got 200 wheels cut out or something, you know. I don't think Sparky realized that John had so many wheels. But when Sparky call up John or on a hangout, or I'd be over there, he'd say, quit messing with that stuff. Get this airplane ready. Lo and behold, old John had a sweatshop going over. He had 200 wheels. Oh, it's all good. Funny stuff, though, thinking back. So you see me massage this thing down. Basically, it'll almost look like pre-preg when it comes out of this bag. I guarantee it. All this rubbing it down. So right now, I'm pulling resin out of the dang bleeder. You know, trying to get more compaction. Let's see here. Let's see here. Let's see here. You got to make sure he's got everything squeezed right out of that. I watched the sheet of carbon fiber explode with the water jet. Okay. Well, yeah. Yeah, that's pretty wild, Robert. I wonder what caused it to do that. I do know this water jet cut, the place I go to, it's in Claremont, and they do a lot of race teams. I've seen carbon sheets in there, 4 foot by 4 foot carbon sheets, and they got like Andretti written on it, you know. So they're doing jobs for race teams. I don't know what part, but they're cutting stuff up for them. But this high dollar pre-preg, I mean, I don't know if that would explode or not. That stuff's so dang That thing is so dense and well compacted. Now maybe if I took them something like this here to the water jet cutter, you know, they might be an issue. But all this stuff here and this, what I'm doing tonight is just going to be hand cut. So I just took this thing here and I made a little template, traced around it, laid out my holes, and then and I cut it by hand. Basically, I just hacked it out on a saw, a metal cutting band saw, and then I took a Dremel and, you know, got my radius in there. I'll tell you what, I sure wouldn't want to do many of them like that, carving them things out. Years ago, there was a guy by flew speed. His name was Ned Morris, and he comes over at the house with 2 bandsaw blades, and they were do-all blades. I'm going to sit on John's stool here for a second. that's why I got his stool. So he comes over here, 2 do-all blades, and I mean, they're good bandsaw blades. The blades were probably more expensive than my cheap Chinese saw. So he has this chromoly sheet, probably about 18 by 18 inches. He's got them all traced out in Daikin blue, you know, and they're Bellcranks for speed planes, and they're small little things, right? And he said, let's cut these out. I want to see how long it takes you. So I start slicing these things out, and it's all got straight lines, you know, there's no curves. And he gave me the blades, those bandsaw blades, and then I said, well, how'd you do? He said, well, I sold them all. He said, it didn't take me long to sell all those Bellcranks. I said, well, you going to do more? He said, no. He said, I called up that laser cutter, and he took one of those Bellcranks, and they were laser cutting the sheets out for him. So we found out real quick, if you want to sell any of this stuff, whether it's horns or whatever, you know, you better pay the money up front to get it cut. And that way you're not out here with blisters on your finger running stuff through the sander. But you know what's neat, I mean, you guys look at this process here, right? You know, I got the plate, and let's just say you flew a lot of stunt and you laid up this amount of carbon. Well, there's 4 Bellcranks here, so if you build 1 plane a year, well, there's 4 years worth of stuff. So, you know, the other thing with this channel, I try to put the information out there, and Sparky and all these other people that have these RC channels, they put this information out there just for people, you know, that want to do stuff like this. So even though I'm going through this whole iteration of laser cutters, water jet, autoclaves, you know, it doesn't apply to hardly anybody, but where I'm getting the process here, it's viable, you know, for somebody who just wants a half dozen or whatever. And the other thing I tell the guys, I said, you know, I don't know how control line clubs are, but I spent $550 on styrofoam, and I got it all stacked in the attic. And I'm not selling wings, but the only way I could buy the styrofoam and make it reasonable was buy that much. So if you wanted styrofoam wings, my suggestion would be get with a club, get one guy in a club, get like 4 or 5 guys together and build a foam cutter, and then all pitch in, you know, so that way everybody gets a couple cubes, you know, once they cut the billet up, or a couple sheets. So you can spread out the cost, you know, if you go to the club route. But yeah, I just like to see more people, you know, get into this stuff and, you know, build. And maybe it's one of these things where, yeah, you're not going to use this information this year, but maybe next year or whatever, or down the road, somebody could use it. So, but to be honest, if I took this part into JT Composites or any composite shop worth their salt, I could take them a prop, a landing gear, I could take them anything, and I'd show them this part, they know exactly how to make it. And I did that. So when I worked at JT, I didn't do any composite work for them. All I did is their woodworking. And I'd come in there, I'd drag a part in there, you know. And it's like this pod here. I'll show you. So I take this plug in there, and here's the part, here's the mold, but I took the plug in there, and just pretend this is a plug. And I said, hey, what do you think? How would you configure the mold? He looked at it. He said, well, I'll tell you what to do. He said, if you want the carbon fiber to end here, you better extend the mold out to here, at least 3/8. You got to get it past. He said, if you're in an autoclave and pre-preg, you got to overshoot where you need it to be, because as soon as that carbon wants to go around a sharp corner of a mold or whatever, he said it's not going to work. So basically he said extend it here or there or whatever, that way the final fit will be, you know, your cut. So, and then I just made this is sort of like just like a little dish, right? It's all enclosed. So the thinking was, let's just say you do this in a high production part. This is a high temp mold, but basically the mold will be keyed together, so you got right and left half. So the mold comes together, but the back is open and the front is open. So it's like this. This is the part. It's open back here, and there'll be a tube that comes out here for the fuselage, and of course, you know, this is open. So the configuration, and I've seen it on a lot of places, it's no big secret. The mold goes together, it keys, you bolt it together, and what you do, you take bag, this like this bagging material, but it's smaller, and you stick the bag through the mold. Inside the mold, it's got carbon fiber pre-preg. So when you put the mold halves together, the pre-preg sort of overlaps, right? You know, sort of comes together, and you put, maybe the carbon will be flush here, but the next side would come over, so it would be an overlap. You stick the bag through the mold, and then you bring it through twice as long, and you turn it inside out, and you pull the bag back over the outside of the mold. So you seal it. So basically when you pull a vacuum on that tube, you just turn inside out, hold it back over. When you pull a vacuum, you're pushing up on the inside of the mold, and you're pushing down on the outside. So the bag will go through, wrap around, and you seal it all off with your puck, pull the vacuum, so the bag would be pushing up inside the mold and on the outside. So in effect, when the part's done, you rip the bag, you pull it out of the mold, you open your mold, and it's done. The seam is perfect. There is no seam. Basically, it's just it's where it needs to be. So that gets rid of all the joining, the tape, and all the other rigmarole. The other thing people don't realize with pre-preg, and there's tooling pre-preg. Now, tooling pre-preg is a really thick, resin-rich pre-preg, and it's made to go into a tool. And then they got pre-preg. It's sort of like maybe tooling pre-preg, but it's set up to where it has extra resin in it. So all pre-preg is different. I mean, there's all different curing cycles. There's all different weights and weaves. It's almost unlimited. So that's how, you know, you go from a West system part, you know, that's just like this, to a high production. Let's see it. This came right out of that mold. So after the fact, okay, I could take this part, or take the plug, stick it back in the mold, take the other clamshell, put it over the top of the plug, and then I could go through there and drill through the flange so I could bolt them together. So let's just say I didn't vacuum bag this part and I want to join the halves. I could join them in the mold. Cut the open part of the mold here. So when you put the part in there, you know, you can join it in the mold, so then you can seam it. The way I do this, I just bring it together and I tape the outside and I tack it with CA, and then I just run the seam tape on the inside. So this is heavy. This is like boat cloth, but it's perfect for this RC stuff. Takes a beating, you know. So I told Sparky, I said, don't throw that 6-8 pound wood away or do anything with it. I said, I'll take it. I said, I'll use it on some of this RC stuff. So let's see. Okay, let me read the stuff here. Okay, talking about where the it's got everything squeezed. Okay, figure there was a small void in it and it migrated. Yeah, I can see that happening. So if you're water jet cutting and that water jet builds up pressure in between the laminate, yeah, I can see how that could happen really quick. That makes sense. And then Sparky says, yeah, when we're dead. Did they know how my tank was made? Well, yeah, they did, because I told them. Yeah, they knew how it was made. But I did tell them, you know. You know, the thing is with those tanks, Spark, I mean, let's just say it was like the heyday of stunt. Everybody's flying IC, and everybody has to have a tank. There's no electric. And just stop and think, if you could have like Doug Taffiner or that Smith guy, I think he made tanks. If you could wrap that tank business up if you had that technology in the old days. You get online and you can see tube manufacturers that make, you know, all different shapes of carbon tube. So like I said, to me, the tank would be buy the tube already made with the right resin. It's like you could spec the wall thickness, you could spec, you know, so it would withstand the fuel. And all you do is take a chop saw and knock off the tank. You could have different thicknesses, you know, of tubes. And, you know, I was telling Sparky, I said, you know, my thinking was with that tube, and I'll go over it real quick. I'll show you something. Okay, so here's a scenario, and I came up with this. So you want to make a tank, and the problem with the tank is if you know how Sparky made, there's no secret. He made them online. So he's got a male mold, and he's got the clamshell outer molds. So he wraps the male mold with carbon, and then he takes the clamshell mold from the outside and smashes it over the top of it, and it makes the tank. I said, here's what you do, Sparky. Okay, here's 2 pieces of angle aluminum. And there's got to be a little bit of machining here. So, okay, so look at it this way. Think of this as a mold, right? You put these 2 angle pieces together, and now you've got an inside dimension right here, right? This is variable right here. So you could vary the thickness of the tank by sliding the mold this way. You can't make it any wider because the width of the tank is based on the angle, okay? But you can vary the thickness of the tank. So what you have to do is you have to weld in little blocks here or whatever so you can adjust that. Or if you don't want to, heck, you just make up some kind of C-clamp or rubber bands, I don't know. So anyway, this is your tank mold. So you lay up your carbon fiber here on the inside of this L, and then you put it together, right? Like this. Well, you can go down there and you can look and you can sort of make sure everything's where it needs to be. You know, you want some overlap or whatever. Okay, this aluminum will take heat and it'll take the 700 NC high temp free coat. It polishes up. So anyway, basically you do just what I was talking about with the fuselage. You put your carbon inside this mold, you stick your bag in there, or you could go with a bladder, but stick your vacuum bag in there, right? You pull it around, you turn it inside out, and you pull it back and you seal it. So then you vacuum bag your tank down. But the thing is, instead of making a 6-inch tank, I'd at least go 24 to 28 inches or maybe 3 feet. So when you make this mold, you make it long enough to accommodate a lot of tank. And here's the thing, when it comes time to release it, you know, you unscrew it and it falls off. So you have, you know, the inside is contingent on how smooth the bag is, but basically, you know, that's one way of doing it. Now let's say you have trouble with the pleating. Let's say the bag leaves pleat marks on the inside of your tank. Well, all you do is put call plates in there. So once you lay your carbon in there, you could take strips of UHMW plastic, put on there, so then when you vacuum bag it, you know, you've got a smooth surface. So that was my thinking. There's your inside of your tank mold. There's your thickness, so you could adjust the capacity by doing this, and you can adjust the length. But that was another rabbit hole I didn't want to go down. So I mentioned it to Spark, but he's got so many projects going. We got so many projects going. We're not going to live long enough. So, you know, yeah, it's and you know, you can make a lot of stuff out of this aluminum. I take pre-preg from the scrap from the shop, and I'd take these molds and I'd buff it out. And I don't have an autoclave, obviously, but I'd take this pre-preg and I'd smash it in between there, and I'd clamp it both sides, you know. And I got some really neat brackets that you make servo mounts or something out of. Yeah, somewhere around here I got a whole bag full of that scrap. So yeah, that's my brainstorming there on the tube tank stuff. So well, guys, I've probably been on here long enough. I've chit-chatted, and you guys have chimed in and helped me out a lot. You gave me a lot of good advice. I'm glad Spark come up with the thinner laminate. That's something I really didn't think of until he mentioned it. I wanted to do it, but I forgot about it. I wouldn't have done it if I didn't think this was overkill. This is really stout. But now I can compare this to this. And that, I know obviously will get the weight down. So I think I've got the same compaction here as I did on the other one. So yeah, I'm tickled about that. Let's see, I got a bag somewhere. But yeah, I'll jump off here. Really didn't cover too much, but did a lot of chit-chatting. And you know, the other thing is, when it comes time to do stuff like this, it's probably good to actually watch it. If somebody starts doing this and they try to explain it to you, and it's not in real time, and they say, yeah, squeegee it down, but to actually see it happen, you know, how long it took or the whole process, I think it helps. And I know the videos are lengthy, but on this remote I got in there, it's got this little button. You just take it and you hit it like this, and it just scoots it right across right across the screen. The other thing I need to do on these videos, honestly, these guys do it on YouTube, but it's just more time. Down at the bottom, they have like a bar, and it says introduction, wetting the carbon, vacuum bag. So they got like chapters, and you can scroll through, or they'll say fast forward if you want to see the whatever. I mean, there's so much stuff I could be doing. Okay, yeah, Robert, take care, and thanks for coming in. So I'm jumping off here, and maybe tune in tomorrow or look for another video. I'll see if I have a catastrophic lockup. I'll see you guys later.